Good afternoon, Bill. You made it. This is the last session of the day, and we're here to talk about, breweries. Now, I am the last thing. Me and Paul are probably stopping you from getting a beverage at the mixer, or maybe you are the last thing stopping us from getting a beverage. I don't know. So we hope to make this exciting and communicate with you. My name is Josh Palma, and I am the PM lead for Azure Kubernetes Service, and I'm here with
Paul Yu, Cloud Native Advocate.
And just a quick reminder, we will be talking about how to integrate with Azure AI and how Azure AI is integrating with AKS to kind of build intelligent apps and have an intelligent service as well. And a reminder for those of you watching here or at home, you can ask a question at any time through our question platform. You can actually, if you're in the room, scan that QR code right there and ask a question at any point. Take it away, Paul.
All right. So let me first start off by saying that neither George or I are data scientists.
I mean, who isn't these days? But yeah, sure.
Right. So we're not here to tell you about all the nitty-gritty details about large language models. But what we are here to tell you and talk to you about is how you can build intelligent apps and, more importantly, run them on AKS. From there, we'll talk about how AI is actually integrated with AKS. It's going to be a demo-heavy session, so please bear with us, and let's get going. Towards the end, we'll take some Q&A, and like George mentioned, on the Pubble app, so scan the code if you haven't done that already. So what are intelligent applications? You probably all know by now that this is a new era of computing. We are in the age of AI. GPT-3 and GPT-4 has changed the game, and things are moving fast, really fast. So it seems like recently there's been a lot of announcements around us adding AI into products. I mean, just look at all the things that we've done with chatbots and copilots, and it really all started with GitHub Copilot, my favorite AI-powered pair programmer. And then from there, it seems like once we announced OpenAI and the Microsoft partnership, the floodgates just opened. We have the AI-powered Bing, the Microsoft Security Copilot, and the one thing that I'm looking forward to is the M365 Copilot that can help me make PowerPoint slides like this. And so we're at the point right now where everybody's flocking to these technologies, these OpenAI models, so that we can leverage them in our applications. But how do we do that? How do we do that with resiliency and scalability in mind? And how do we do all that while adhering to the 6 core principles of responsible AI? The goal here is for you to run fast, but not break things. And this is why we would suggest that you take a few things into consideration. Number one, when you're working with these AI models, leverage a framework or an SDK that can help you easily integrate AI into your apps. And then more importantly, look to services and platforms that can help you meet your resiliency and scalability goals. And let's see how. So let's talk a little bit about this demo application that we're going to show you. And we're not building anything net new. This is an existing application. And I like to watch old home renovation shows. And so this is kind of like that project. We have an old application, and we want to add intelligent capabilities to it and literally bolt it onto our application while taking on minimal risk. And so there are some things that we want to do with our application. For instance, we want to enable a chatbot for our app, but we want to put it behind a feature flag. So we'll do that. There's also some advantages that we gain when we host it on AKS, including scalability and resilience and things like that. And so we'll explore a couple add-ons that are available to us, because what are we trying to do? We're trying to run fast without breaking things, right? So we are going to host the chatbot as a microservice. And I hear that when you're hosting a lot of microservices, it plays very nicely to a service mesh.
Oh, yeah.
So what's the deal with service meshes?
Well, what's the deal with service meshes? What a loaded question for this time of the afternoon. Well, and you're absolutely right. They do play really nicely with microservices. Really, the advent of microservices and service mesh really came together kind of as a whole as well. And it's really a layer of infrastructure you deploy into a Kubernetes cluster to kind of help you. And it helps you with many concerns. Kind of 5 are the most common ones, even though there's a myriad of features that you really can leverage. On one hand, service discovery. Really, you want to call other services within the mesh using names that are automatically added to a service registry so that you don't actually have to manually cobble all these things together. You want to also have ability to have traffic management and traffic routing, which is things like, for example, doing traffic splitting, controlling where it goes, how much traffic goes into which direction, and we're going to take a look at that later in this session. You want to look at things like security and traffic encryption, MTLS, mutual TLS, how to get information from service A to service B in a fully encrypted and secure way. You also want something that helps you improve your app resiliency, which is why having things like injecting faults or implementing different features within your infrastructure, your service mesh, can help you. And then finally, observability. As you go into a world of microservices, like in this case we're demonstrating with a very simple microservice, but it gets much more complex as you go into a myriad of microservices or a mesh of microservices, you start to get a little bit lacking in terms of observability capabilities. Like how do you troubleshoot from the calls for so many of those, or the mental model of services that you have now, the logging, how do you aggregate all that logging, how do you index it? It becomes really, really hard. How do you ensure you're capturing all the logs, not losing? And so service mesh and something like a SACOP pattern or sidecarless pattern that actually is able to capture that by microservice can help you tremendously. But if I said a lot of things, it's because the service mesh does a lot of things, but it's also a little bit complex to manage, and it also has a few complexities for you to operate. And that's why very recently, a couple of weeks ago, we're very happy to continue our innovation through the service mesh space and announce the Istio Service Mesh add-on on AKS, currently in public preview. Istio is the market leader in terms of service mesh. It's the most used service mesh in the world. It's Envoy-based. It has a bright future ahead, a vibrant community, a lot of features, and continue to have a lot of development on it. But as I mentioned,
so like, what are we gaining out of it becoming an add-on in AKS?
Nothing. Just kidding. So we're gaining a lot because even though Istio is fantastic and it's great, as I mentioned, it's a little bit hard to operate.
Yeah.
It's a big beast, and as you have to coordinate things like compatibility with the Kubernetes version, or you have to coordinate things like the different pieces of your cluster and how they work with Istio at different scale points, or how you, even though it leverages emission of data and observability from your microservices, where are you sending that data and how is that integrated? Do you have already Prometheus and Grafana configured? Do you have some other monitoring service? How out of the box is that? Typically, you need to hook that up as well. And then, at the end of the day, being such a complex machine, you definitely want to have support. You have someone to call, someone to ask questions, someone to support you when there's any issue, if there's any issue. So those are, if you reverse them, really the benefits of the Istio add-on in AKS is that you actually have out-of-the-box integration with Prometheus and Grafana, which we're also announcing the GA right here today at Build. You have the ability for AKS to manage the lifecycle of your Istio components. So AKS actually maintains that compatibility with the different Kubernetes versions. When you upgrade your cluster, we also upgrade the Istio control plane to actually match that Kubernetes version.
Nice.
And we actually are scaling and adapting and optimizing the different components, like Core DNS, for example, to support the different scale points of Istio and the operating models. And to finalize, we actually have a few nifty features on top of that, because with something as important and fundamental as service mesh and Istio as an example, you actually are able to break yourself in many, many different ways. That's the truth. And so we didn't want to take complete over your cluster and your data plane. Istio has the control plane and your data plane, and we actually have a fully managed control plane that you see right there. We offer you the different ingresses, be it external or internal, so you can expose things internally and externally through the Istio gateway. But here's a key thing. Once you upgrade your cluster, as I mentioned to you, we actually upgrade your service mesh control plane as well. But your data plane stays as is. So when you finish the cluster upgrade, you can actually manually, and by namespace or whichever way you want, roll out your workloads to receive the new data plane components. The sidecars themselves get updated to the same version as the control plane. And once, if you don't do it, and you try to upgrade later on, we're going to block you and say, hey, your control plane and data plane are out of sync. You need to kind of get them back to sync and then upgrade the cluster. So you still have the benefit of a fully managed solution, but still the control to actually ensure the reliability of your services. And, as Paul says, go fast, but
without
don't break
breaking things. Yeah.
Take it away, show us our app.
Yeah. So let's talk about the application in its current form. So this is the eShop on web application. It's an ASP.NET MVC app, and it's hosted on a Kubernetes cluster. The application gets its data from an Azure SQL database, and our cluster is actually scraping. The metrics are being scraped by Azure Managed Prometheus, which just went GA today. And to visualize all those metrics, we have it integrated with Azure Managed Grafana as well. And then we have Istio in place. Now, Istio is great to connect microservices, but it's also awesome because it offers an ingress point for us, and that's fully managed by Azure as well. And so when any users want to hit our website, they come in through the Istio ingress, and that traffic gets routed to the eShop application. This is the current state. Where do we want to be? We want to add AI features into our app, right? First thing we need to do is we need to provision an Azure OpenAI service. This is where we can take advantage of OpenAI models like GPT 3.5 and soon to come, GPT-4. In order to talk to the large language model, we're going to build a brand new microservice called the Chatbot API or Chat API. And we're going to use the ASP.NET Minimal API framework here, keep things a little bit simple. And we're going to leverage an SDK, the semantic kernel. This will allow us to talk to the Azure OpenAI services pretty easily. That takes care of the back end for us. What about the front end? What we're going to do is we're going to drop in a Vue.js component. We'll write the Razor syntax for a partial view, and we'll wrap it around the Vue.js, and that will serve as our front end component. Now, remember we said we want to run fast without breaking things? Well, we want to release the chat feature when we are ready. And so to do that, we're going to put it behind a feature flag, and we're going to leverage the Azure App Configuration Service, which has the capability to offer feature flag. And so we'll do that. And once AI is in your application, your website's going to be awesome. You're going to get a lot of traffic to it. And now you're going to have to make sure that it can scale appropriately. And from here, we'll take advantage of another add-on, Kata, the Kubernetes Event-Driven Autoscaler, to ensure that our web app can scale out and handle the demand as needed. And to ensure that Kata is scaling appropriately, we'll also integrate it with Azure Load Testing Service, right? This is a serverless app that can load test, and we can make sure that it's scaling appropriately. So here's where we want to be. Let's go check it out on the demo.
Wow, full load package. I'm excited.
All right.
Check it out.
George, I've actually built the application and pushed it to my GitHub repo. Mm-hmm. The GitHub action is running, packaged a container, scanned it, and pushed it to Azure Container Registry.
That's cool.
Can I deploy it?
Let's give it a shot.
All right. YOLO, right? Let's go. So what I'll do is I'm using Kustomize to customize my deployment. And I'm going to release the Chat API version 1.0. And I'm going to also release a new version of the web application. And this includes some of my front-end changes. And so what I'll do is I'll add that to my customization file. And then I'll go ahead and deploy the service. So I'll let that deploy. And while that deploys, well, we'll first see that we have the Chat API version 1 created. And we have Istio components also created. Mm-hmm. So we're using Istio's virtual services. Now, let's take a look at what the Chat API YAML does for us. Just a plain old deployment and a service. Inside the virtual service, it's part of the Istio application. It's using the Ingress Gateway, which is also provided by Azure. Here, I can configure a custom route. So anything that goes to /chat, that will be my Chat API, Okay, so let's see if the cluster is ready. And I can see here that we're just waiting for the readiness probes and the liveness probes to complete. Give this a second or two. And we can see here that the chat API is ready to go. Now, I want to perform a test on it before I release it. I want to do a curl command, but George, I know the public IP is in the ingress somewhere inside of the services. Do you remember the command to get that out?
Of course I do. I've been working with Kubernetes for many years. I just happen to not remember right now.
Oh, I know. What I can use GitHub Copilot CLI to go retrieve that information for me. So if I issue this command to GitHub Copilot CLI and ask it, give me the ingress IP of this service in this namespace, I can go ahead and ask for that. It'll think about it, and it gives me the query. Does that look OK? That looks OK to me.
Hold on. Yeah, OK.
OK. But what I want to do is I want to save this value into a variable. So I can revise the query and say, set the value in a var called ingress IP. So it'll think about it again and perform the action. And I'll actually run the command now. So I executed the command. And now, if I do a echo, I have the IP address. Now, if I do a curl, I have the chat version 1.0 running.
Nice.
Let's go ask it a question. I'll ask it, do you sell mugs? Now, while we wait on that, let's take a look at what I am expecting. So here is the microservice that we have in place, and it's using the semantic kernel for that. And the semantic kernel allows me to just configure it for the Azure OpenAI models that I want to use. Inside of the application, I only have two endpoints. One is just a get that will give me the version, and the other is some prompt engineering. Now, this is hard-coded here, but I'm telling the bot what it can and what it shouldn't do. And so here I'm saying you are chatting with potential customers, and here are the products that we sell, right? So there's a white mug and a cup of tea mug, which is probably my favorite product in the store. And the chatbot answered. It says, yeah, we have mugs. We have the .NET Black mug and the cup of tea. That's awesome. So I'm ready to push this out to production on the front end. And what I'll do is I expect a chat icon to show up right here. Okay? But remember, it's behind the feature flag. So what I can do is I can head over to the Azure App Configuration Service.
Wait,
and
what is that?
So Azure App Configuration Service is a service that allows you to manage key value pairs, secrets, and feature flags. And so I have my code written to call up to this particular service and retrieve data.
All right, nice.
Yeah. So what I'll need to do is I'll just need to literally just check this box, and the thing is enabled. And so after a few refreshes, maybe 2 to 3, there. Now we have the chat icon right where I expected it. So what I'll do now is I will ask it a question. Do you sell red shirts like the one Scott Gu wears?
Not going to know who Scott Gu is.
It has. It knew exactly who Scott Gu is.
No way.
It said Scott Guthrie. And it says, no, we don't sell that, but we sell Roslyn Red t-shirts, which here it is, the Roslyn Red t-shirt.
Indeed.
Wow. Amazing. What if, from there, we iterate on the chatbot and we want to make it better? Well, we can use capabilities of Istio, the traffic routing, to darkly launch features, right? And so we can do that. Let me just go ahead and deploy a new file there. And I'll bump my chat API version up. And then I'll go ahead and deploy that. While that's deploying, let me quickly talk about the dark launching feature that we have enabled. So what we can do is a couple new things with Istio. One, destination rule. I am naming my destinations. We have 1.0 and then we have 1.1. Using those names, we can then route traffic based on whatever rule we have in place. And so here I'm saying anything with this custom header, with this value of BRK225H, which is this session code, it'll route me to the updated version of the service. So let's go check it out and see it in action. So what I'll do is I'll first make sure that my 1.1 pod is ready, and it is nearly there. Let's give it one more check. Okay, there we go. So now I can issue another curl command. This gives me 1.1. Now, if I pass in a custom header of X Istio MS build and the session code, it'll give me 1.1. So that'll allow me to deploy a new feature and slowly release it.
So kind of could like have this header like in your browser, and you pass it on, and then you.
Yeah, exactly. Or I could let only a few folks access to it, right, using that header. Now,
what if you want to do like something like differently, like you actually want to control how much traffic goes into different ways?
Aha. So we could do that using traffic splitting via weighted distribution.
Oh, cool.
Yeah. So what we can do here is there's a new YAML that I have down here, and nothing changes with the destination rules. That all stays the same. The only difference here is now I have two routes with the weighted distribution. So here I'm sending half of my traffic to 1.1 and the other half to 1.0. So let me go ahead and update my YAML manifest. And then I will deploy a new version. And there, we see that our virtual service has been configured. Now, what I can do is I can run a continuous curl to this application, and then we'll start to see the traffic being distributed to 1.0 and 1.1 pretty evenly. And when you're ready, you can change the weight distribution and send 100% of the traffic to 1.1 and 0 to 1.0. But do we want to do that manually? Not really. We want that to be automated. And we can do that by using Flagger. Flagger has an integration with Istio so that it can automatically deploy the destination rules and the virtual service and the different versions for us. And so what we would need to do is, number one, install Flagger. That gives us the ability to create this new manifest of kind canary. And we can tell it what deployment to look at. We can tell it what services to also look at. But here's the cool part. It can analyze our traffic and determine how much to increase the weights. And so here, just for demo purposes, I set the max weight to 20. So as soon as it reaches 20% traffic to the new version, it's going to cut all the traffic to the newer version. And what we can do is we can tie it in with some internal webhooks where we can do some acceptance testing and load testing and make sure that we have a solid deployment before we actually release it. So I can't demo this to you because it takes a little bit of time, but we'll cut to a quick video that shows it to you end to end.
There goes the cooking show.
That's right. So the first thing that we do is we use Helm to install Flagger in the Istio namespace. Once we've ensured that the Flagger components are running in the proper namespace, then we can go ahead and install our Flagger load tester. And this load tester is actually run in the same namespace as our application. So now we're pretty much ready to go and use Flagger. From there, what we'll do is we will reapply all of our manifests, which includes Canary. And note here, we don't have a destination rule, and we don't have a virtual service for the chat API. What we'll need to do is we'll wait for the pods to come up, and then we'll make a change to the app.
Good. So our app there is what?
So our app here is the chat API, but have you noticed there's a slight change? There's Dash Primary.
Dash Primary, yeah.
Yeah. So what Flagger is doing is it created a primary deployment. This is essentially our production version of it. And the non-primary is the canary, right? And so what happens with this is as canary is deployed into your cluster, it initializes and sets up these two services for us with 100% of the traffic going to primary. And it also created the destination rules we needed and the virtual service for the chat API. That was all automated for us. The next thing that we can do is, number one, we'll grab the image version, make sure it's 1.0. What we then do is we update that image version to 1.1. From there, the canary actually detects that change and says, hey, I got some work to do, right? So what you'll see is that it'll start progressing and performing its tests. And so if I put these two windows side by side, we can watch the progression, and then we'll watch the continuous curl commands, and we'll eventually see all the traffic being shifted toward the latest version.
So it's going to start really slowly on, version 1 to version 1.1, and then it's going to actually pick up and go.
Right, yeah. And as it's progressing through the levels, it'll do its load testing and acceptance testing.
Very good, very good.
Yeah.
So we see basically quite a lot of 1.0s now, and then 1.1 is going to start showing up more.
Right.
Yeah.
Right. And then we see it progressing at 20, up to 20.
So that's the time that it's going to,
Yeah,
speed up.
yeah, because it's a demo, so I only wanted up to 20% of traffic. And then eventually, what happens is it passes all the tests, and Flagger promotes it. And now you see all the traffic being shifted to version 1.1.
Nice.
Nice. So with that, we have our intelligent application. We have an automated deploy that we can safely deploy. And now we need to show how we can scale the application, right? So what we'll do is we'll create a new YAML manifest because we have Kata in the cluster, but we don't have a scaled object. And
Wait, you're going to create a YAML manifest live from scratch?
Yeah, I don't have it in my repo here, so let me...
You're going to do it from scratch, live?
Yeah, let's do. GitHub Copilot is in my VS Code.
Ah, okay, you're using an assistant. Okay, fine.
Yeah, I'll use that to help me write it, okay? So what we need to do here is we need to give GitHub Copilot a prompt. And so what I will say via comment is Kata scaled object for web deployment using CPU trigger. Now, GitHub Copilot is not autopilot. It's not going to write the entire thing for you. You do need to nudge it along a little bit. And yeah, you see the little ghost text there? That's GitHub Copilot doing its thing. And so what I can do is, oops, hang on a second. I'll accept this, but I know this is not the correct URL. That is. So you do have to make some modifications along the way.
You're definitely doing it live.
But for the most part, this looks good. Namespace is not good, but I'll stick with it. I'll change it in a second. And what I'll do is I will nudge it along and give it the name of web, give it a trigger. So I'm literally just typing through it. Type, and I'll say CPU, because that's the trigger that I want. And then I'll say metadata and value. Nope. And I'll say 20, but I also need a metric type. And so I'll start typing, and I can auto-complete that. So that looks okay.
20? You're doing 20 or 50?
Oh, let's do 20%. Yeah. Does that look okay? Looks okay to me. So what I can do is I can apply.
Who notices that he's going to mess up live?
Let's do this. Come on. I try to tab complete that. So let's do web scaled object. YAML. Did I save it? Let's grab that. Maybe I spelled it wrong. Oh, I know what I forgot. I forgot the dash F.
Yes, you did.
Yes, I do need to pass that. Now, I don't have
Points
a
for those who
deployment.
raised your hand.
I did say I was going to fix that.
Yes.
Yeah, sorry.
And yet you didn't.
Yeah. So if I apply it again, there we go. Scaled object created. Now, I can show you the load test, but that also takes some time. So we'll cut to another video where we'll see it in action end to end.
Cue the music for the cooking show. There we go.
So here I'm using the Azure Load Test service. And what I'm doing here is I'm creating a quick test on the application. If you have JMeter scripts from on-prem JMeter or wherever, you can load those as well. And so I'll run a load test to simulate 250 users over the course of 7 minutes. And I'll ramp up the users over 60 seconds. And so what we'll see here is that once the test goes, Kata will start detecting the increase in CPU load and will expand or horizontally scale out the pods. So we'll wait for this to go. And when we do this, note the P90 response time on the home page. So we spiked up our user count.
Ooh.
And 30 seconds. Does that sound good to you?
I'm not waiting for anything for that.
Yeah. So you can see that the count the P90 is starting to drop dramatically. And the reason why is because Kata is doing its thing and horizontally scaling out the number of replicas. And eventually you'll see that it'll drop all the way down to a more bearable response time. And Kata will eventually detect that CPU is low and then scale it back down when needed.
Very cool.
So that's load testing. And that's a way that you can add intelligent features to your app. Now, what are we doing in terms of AKS to add intelligent features to that?
Take a look.
Yeah.
Okay, so just a quick set of like what we've been doing here with Flagger. And let's now take a look at how we actually have been, what we've been doing, what we've been working to actually, put AI in everything, everywhere, all at once, in this case, in AKS specifically, and in which way it can help you. So as you might have seen in past presentations, or if not, I'll recap for you. In AKS, we really are working to empower you to differentiate, to innovate, to be productive. For this, we really have been harnessing the power of Kubernetes, and we want to continue to provide it to you untempered, unaltered, with its full power. But with AKS, we want to provide it in a way that is managed for you, so you don't need to operate it, you don't need to worry about, the backup, the control plane, the configuration. And we've also been working tirelessly in providing an ecosystem of tools that enable the bootstrapping of that experience to make it much simpler to you, be it from monitoring or development or backup or policy. By the way, there's a lot of icons there, and there will be a test about this before you leave to make sure that you know all of those icons. And if you do know all of them, just seek me at the end and I'll get you stickers or a beverage of your choice, because that's quite a few.
He said it.
Yes. But it's not just that, right? Like, we also want to make sure that we are able to help you not just have a slide of logos, but actually use them effectively, even somewhat continue to bootstrap that experience and simplifying it, providing you with the choices and the help similar to what Paul had with Copilot and with all the help that he's got throughout his session. And so we're really, really happy to announce the AKS Copilot, an AI-powered assistant for Kubernetes that will enable you to streamline your operations, reduce your skilling efforts so that you don't have you or your teams to have to learn Kubernetes all at once from scratch and know everything there is to know about it. You can actually decide how much you want to go, how deep you want to go, at which point, and really, really create your own story to ramp up to Kubernetes and have as much help or as little help as you want, and really dive deep on the things that matter to you and less deep on the things that don't. It's really all about empowering your developers to continue to focus, yourself if you're a developer yourself, or your teams to really focus on what matters, your code, your business logic. And as it's our custom, this is available for free for all your clusters so you to start using.
I like free.
You like free? I like free as well. So let's take a look at what this looks like. So right here we have your trusty Kubernetes cluster, and we're going to add. I saw Paul kind of, fighting with the scaler there. So I'm going to show how this actually looks like when you use AKS Copilot. All right. So take a look at this, Paul, and see if it looks better or not. So I'm going to tell it to create a Kdescaler object to scale an Nginx deployment with a CPU trigger.
Oh, okay.
Same as you.
Yeah.
And utilization as the type, same as you.
Okay.
And just a difference 50. That's why I asked you to do 20, so that we know it's different.
Yeah.
And look at what's going to happen now. You're going to actually have automatic completion on the portal editor. That looks way better to me, Paul.
On the first try.
On the first try.
Wow.
Proper API, yes.
Yeah.
And you can just go ahead and see your CPU type there. You can check everything is appropriate, including the value, and you can just go ahead and apply it right now. So
that's nice.
Good. It's pretty good.
Yeah.
What about doing different things, right? What if we want to actually ask it for some help? Hey, I'm having some issues, and maybe I want some help answering some questions or troubleshooting something. So you can just pop right in the AKS Copilot and say, hey, show me the minimum, the maximum, and the average of the node CPU usage. And who likes to actually craft your own queries? And there you go. Your own queries.
A
yes.
query.
Yes.
That is awesome.
Look at that. You can just copy, okay, let's actually see if it works first. Okay, those applauses might have been unwarranted. We don't need the help. We have an assistant. We can just go ahead, copy paste it, run it. Come on.
Wow.
And there we go. And we can go further. We can go, okay, something suspicious is going over there, maybe in 02, maybe in a different one. Actually, everything looks fine, but let's pretend something is going wrong. And actually, I want to go further, and I want to see, tell me maybe the same, but for my pods. Okay, tell me the min, max. You can say, percentiles. You can talk about whatever you want. Go ahead for it and show me the min, max, and average for pod CPU usage. And there we go.
Nice.
Generates it again, and you can just go ahead, copy paste it again, and see. So really helping you with your day-to-day tasks, with your queries, with anything that you want. Tell me how to scale this. Create me a YAML for this. Give me an option for that. You can use it for everything that you do every day. And again, it's a Copilot, so you still decide what to do. You can reprompt it. You can do as many things as you need. And there we go. Look at that. That's our metrics server happily running there. That's our node driver register. All good. That's our pods. They all look good, hopefully. Otherwise, I need to actually do some more debugging. But wait, there's more.
Oh, there's more.
There is more.
All right.
But what if we go into the cluster? So there's actually two projects that our teams have been working on. One of them is called kubectl AI, which is a plugin for kubectl, as the name very promptly indicates. And for those of you that maybe, let's use the CLI and let's interact with this a little bit. You can just go ahead and say, hey, create me a deployment using this image, which is my first Node app, and create a service for it in the demo namespace. Just figure it out. There we go.
Wow.
Does that look good to you, Paul? Analyze that. Does that look good to you, Paul?
That looks pretty good.
All right, so we got 8080.
Yeah.
We got your first app, the demo, namespace. All good there. Port 80, target port 8080, mapping up there.
Okay.
The cluster IP looks great, right?
Yeah.
So let's just do a port forward. I'm going to map it to port 80, of that service. And I'm going to say port 4000, so 4000 to 80. Everything is running. Yep, 7 seconds. All good, all good, all good.
Yep.
Let's port forward. Again, 4000 to port 80. And we're going to access it. Right?
Okay.
We're going to go to our browser, access that port 4000.
Let's see.
And everything should work fine, right?
Oh.
No! No! Wait a
going
minute.
on?
What happened? You all see
hang
it.
on.
You all see it. What
This is a
happened?
test. This is a test.
Any guesses? What happened? Uh-oh.
Can't be port forwarding.
It's not the port forward. I mean, we ported to port 80.
Yeah.
So let's actually ask an assistant, shall we?
So
This is Cube Copilot, our friendly assistant that actually goes into the cluster and helps you troubleshoot things inside the cluster with the context of the cluster itself.
kubectl commands?
You're going to go straight into. So you're going to go ahead and ask. Cube Copilot has 3 modes. You know, you have audit, you have diagnose, and you have execute. We're going to see diagnose right here. So we have our pod right there.
Yes.
It's running. See, there's nothing wrong with that pod. It's running happily. And you're going to say, hey, Cube Copilot, please diagnose this pod. What happened? Nobody here guessed what happened, right? So let's see. It's going to enter into this executor chain. And it's going to say, what is going on here? Everything is fine. I mean, it's running. The describe looks fine. I don't know what's going on here. Let me pop some more information, have some thoughts going on. I mean, everything's fine. The logs seem fine. It seems to be running without any issues. Let's see the log, see what's going on. Oh, there's an observation. It's like, it's listening on port 3000. Hold on a second. What was the container port that the deployment had?
We did 8080.
8080. That's the default for, like, you know, applications. So we just stole the image. We're a little bit too eager. So actually, let's go back into our kubectl AI deployment. And now we go there to like, oh yeah, 8080. Yeah, that's not going to work. Let's just reprompt. And we're actually going to reprompt that and say, hey, maybe change our container port to what's actually on the Docker file, which is actually port 3000.
Node.js applications listen on 3000.
Of course, but we didn't say it was a Node.js application. So we're just going to apply and look that the target port actually automatically changed as we just changed the container port. So it knows what should be mapped where. And we're just going to apply it. And we're going to have the most, not like your apps are beautiful. But if everything is fine, this one is the old one. Now we have the new version of the replica. Let's do our port forward again.
Let's go.
No magic tricks here. 4000 to 80, still same command. We're going to access it and have the most satisfying application ever. There we go. Woo. Hello world. Thank you so much. AI, everything, everywhere, all at once.
Yes, right.
So the last one that I really want to show you really quickly is actually how you can do execute as well. So really simple way, you can actually say, hey, check my AKS node CPU consumption. Each node has 2 CPUs. And are my nodes overutilized? Just figure it out for me. Just check it out. What's up? So, hey, what's your cluster? Well, my cluster is this one. OK. Sounds good. That's your cluster. So I can run, you know, top nodes, and it just goes, and you can actually see. And I mean, you actually already have your answer right there, but it's going to do a bit more. So what's your threshold for your utilization? We're ambitious. 50% is overutilized. So say like, hey, I finished my chain. The nodes are not overutilized at all. I checked it. You gave me your observation from a human perspective. Everything is fine.
Nice.
So you can really, really, really answer your questions and improve your day-to-day productivity there.
Yeah.
So really quickly, the takeaways from us here is really AI is revolutionizing the way that we do everything, the way that we develop, the way that we provide information and provide services to our users and customers, and the way that we have our day-to-day tasks done and helped throughout. We really want to make sure that we run fast but don't break things. And in order to do that, we definitely want to have anti-fragile apps. So if you don't know the concept of anti-fragility, it's a great book about it. You can check it out, definitely recommend it. But it's really all about being the opposite of fragile. And there really isn't a good word for that. You can use resilient, but that's different. It withstands something. But anti-fragile is really about it improves over time with that pressure. So things like you load test it, you're able to do different traffic splitting, and it improves your app continuously, and you can run fast but do not break things. Right. And then you leverage a platform like AKS to actually be able to operate at any scale and scale with you. We have great sessions for you today. I definitely like to call out that last one also because I'm presenting, and Ahmed, who's one of the SMEs that is furiously answering your questions on our apps, is also going to be presenting there. And we're going to show a lot about the productivity of development and several great sessions on AI with GPT-4 and AI solutions with semantic kernel. So definitely check those out. and several resources for what's next. I think we might have time for one question, but we will be outside around the exit of the room as well as in the mixer with a beverage in hand. I asked for a beer at the end of this, but I think that got the notice, but I'll be around as well. So the question that we got is there a minimum Kubernetes version the cluster has to be to enable AKS Copilot? No, it just is there in the portal for any version. See, do we have time for another one? We do not. We say we do not, so we have questions outside. You still got able. Thank you everyone for coming. Have a wonderful build and see you tomorrow.